Bruce has asked me to give some reflections on what I'm seeing in the field and math pathways. And it is stunning to see how much good work is going on at the local level and state level in redesigning math pathways and the active role that mathematicians are playing in it. And the big shift, we're awash in a sea of innovation, particularly in community colleges, which are good at innovation because their mission keeps changing. But everywhere, every day, people are working on improving the pathways for the sake of their students. The big shift is more and more places are looking at working at scale. And I want to say a few words about the risks and opportunities of doing this. And first, there are skeptics. Whenever people talk about changing higher education, people have all kinds of jokes that it's like carrying bones from one graveyard to another. But the truth is that higher ed has always been responsive to changes in national need, especially changes that affect funding formulas. And the basic patterns of funding our institutions have shifted from enrollment to completion. And that means that institutions are taking change seriously in ways that they didn't before. In the past, people thought about symbolic responses, pilot projects, study groups. But now, because the core funding and lifeblood of the institutions depends on completion metrics, people are really working on this in the real system rather than off on the side in like 5 sections of a couple of hundred students. So 2 things that I want to point out around math pathways. The first big shaper, one of the reasons we need to work not only locally but at scale, is because all the research shows students are consuming their courses completely differently than they did before the recession of 2008. In Texas, 70% of all baccalaureates last year, 70% of them had community college credit, and 2/3 of them had 3 or more semesters of it. It's 2/3 of all students in the university system of Maryland, baccalaureates, that actually had community college credit, with 2/3 of them 3 or more semesters. So our students are going to more institutions to complete their higher ed work, which means that we can't only innovate on our campuses, but we need to produce a coherent system without uniformity, a system that allows us to be responsive to our institutional culture and student needs, but also in a coherent system that allows students to transfer and for those transferred credits to be part of their degree programs, not just electives. So our students need us to work at scale, not to work just in particular classrooms. The second is the extraordinarily positive changes in mathematics and its role in all fields. And this is a big change. Labor economists have pointed out that in the last 15 years, it's different than before 2000 when people progressed in one career. Now people move across careers, and HR directors and researchers have found that math competence is the primary tool for being able to move from A to B. So our students really need math, and the question is, what's the right math for them? And I know that's been discussed previously. So let me say a word on behalf of college algebra, not the old cranky version, but the reform version, the crafty version that many math people know about. We not only need pathways into the majors that don't require calculus, which is most, but we need to rethink the pathways into those important STEM fields that do require calculus. And the college algebra pre-calculus pathway that worked so well for students 20 and 30 years ago is not working now. In several systems where we've had complete data, 1% of students who take differential equations or linear algebra start in college algebra or pre-calculus. That's a stunning transformation that David Brissou and others have really documented in large data sets. So when we think of multiple pathways and prerequisites, We need to think of the calculus pathway and making sure that there are real opportunities for students to succeed in it. But we need to look at the broad area of programs of study, meta majors, and figure out which ones need statistics, which ones need quantitative reasoning, which ones need workforce mathematics to advance our students' objectives. And we have to keep in mind that 10 to 20% of their students, when they succeed in pathway A, will be emboldened to raise their aspirations and move to pathway B. So at scale, we not only need to build these requisite structures for enabling students to move into to and through gateway courses, but we need to start the planning work for serving well the students who change their mind as the result of the confidence they have when they succeed in math pathways, different from college algebra if that's where they need to go. So these changes, we have to understand our student demography and how students are moving around in our systems when we design at scale. So now 8% of all new community college students already have their baccalaureate degrees. 70% of the students in 3 big systems that are getting accounting degrees from community colleges, IT degrees, and nursing degrees already have their BAs. And they're overwhelmingly majority students. So as we build the math pathways, we need to look at the policies to ensure that those students truly have access to the careers that support middle-class lives. And I want to say to the math people in the audience, we should come at this from a position of strength. We should listen to the people who criticize us justly for high failure rates and for the inability to modernize, but that's not the world we're in now. If we look at our professional associations, AMATIC, the Conference Board of Mathematical Sciences, Common Vision 2025, which is the 5 education chairs of the major professional associations that address undergraduate mathematics, TIPSY Math, which is the primary voice of the senior research community in mathematics, the Board of Mathematical Sciences and Applications of the National Research Council, have all said we need to teach the diversity of mathematics and pick the right pathways connected to the objectives of our students. And they've also all acknowledged that students will change. So that's the new work. We have pretty good evidence that co-requisites, the NMP models, the Carnegie models, the ASAP models, the models that Peter Adams have developed, what Tristan is doing, are showing really positive effects. Although we don't have proofs yet, we have a preponderance of evidence, enough to give us the courage to work at scale. So let me leave you with the notion that we have to work on our own campus, and that is very messy, but the forces are with us. And we can take the courage to work at scale from a position of power, because all the professional associations, the voices of our profession, are saying this needs to happen. That was not true with calculus reform, which was always seen as a radical band of progressives. Now it's the mainstream forces in our society saying this is what we need for mathematics, and it's what we need for the country.